This is the first lesson for section 20.2, and it will discuss the parabola. Now, the parabola is something you're probably relatively familiar with. It produces a formula that has ax squared plus bx plus c, so we've seen this before. Any of the quadratic formulas produce a parabola, but we're going to get into a definition that's a little bit different today. So, the definition that we are going to use for a parabola is a collection of points that are the same distance from a given point as they are from a given line. So again, we're looking at the definition with regards to a conic section. Remember, splitting that cone up. And the given point is called the focus, and the given line is called the directrix. And we'll talk about how we can use these to find the equation of a parabola. Again, if we think about a parabola, typically we think about something that looks like this, and that's fine. It could also be facing down. Again, this would be x squared plus b. This downward facing one would be something like negative x squared plus b 2. But we can also think about parabolas that lie in this direction. So this might be something like y squared plus a, or similarly we could have one facing this way that would be negative y squared plus a2. And so we'll talk about how we can use the focus directrix, vertex, and then the axis of symmetry to figure out which direction our parabola is facing. So the vertex is the highest or lowest point on a parabola, and again, this is a parabola that looks like this. If we're talking about the y squared, then it would be the leftmost or rightmost point. We can also define this as the midpoint between the focus and directrix. So, if we recall, the standard form for a parabola is either ax squared plus bx plus c if we've got one of these up and down facing parabolas, or x is equal to a y squared plus by plus c if we've got one of these left or right facing. If we're dealing with a up and down facing parabola, then our vertex has the x location of x is equal to, again looking here, negative b over 2a. That will get us our lowest point. So our vertex would be at negative b over 2a, and if you plug that into the formula, f of negative b over 2a. And if we're looking at one of these left and right, then y is still equal to negative b over 2a, and then our vertex, though, is at the function evaluated at negative b over 2a and negative b over 2a. So again, it's a y coordinate this time, so it would be in the y position. So the last thing we want to talk about as far as describing a parabola is the axis of symmetry. And the axis of symmetry is the line about which the parabola is symmetric. This is the line perpendicular to the directrix, because again the directrix is a line on which the focus and vertex lie. So again, if we kind of tried to think about this in picture format, and I'll just draw a typical upright parabola. If we have a parabola like this, our axis of symmetry would be here. Our focus here, if we're trying to think about this, our focus would lie somewhere here. It would be a distance to a point, and then that same distance down would get you to the directrix. So again, that distance from the focus to the parabola line and from the parabola line down to the directrix has to be the same. And then finally, we have our vertex here, which would be our lowest point in this case. And again, it's going to be halfway between the focus and the directrix. So now we're going to take a look at how we can use this information to draw some graphs. So in this case, we've got an x squared equation, so our vertex is going to be at negative. Again, a is 2, b is -1, c is 2. So we've got negative, -1 over 2 times a is 2. So it ends up being 1/4. And if we plug that back into our formula, we end up with a point. Again, you could convert that to a decimal if you wanted to, 0.25. We end up, if we plug that into our formula up here, f of 0.25 equals 2 times 0.25 squared minus 0.25 plus 2, which actually gives us a 1.875. So we can plot that point. That's our vertex. We're at x equals 0.5. So if this is 1, 0.5 would be about here. And y is 1.875, so it's up a bit. We need to adjust our axes again here, so we'll just kind of double everything. -2, -4. So this would be 2 and 4. Again, if we're trying to plot our vertex here, it's at 0.25, so about here, and then 1.875 is about there. The next thing we know is that our axis is going to be along that, so our axis of symmetry is the line x equals 1/4. And then we can find some of our intercepts. Again, looking here, we notice that since our vertex is here and our parabola is opening up, we're not actually going to have any x-intercepts. All we're going to have is a y-intercept. And our y-intercept in this case is at 2, because if you plug in x equals 0, you just get 2. So we can plot that point as well. And so we know we've got a parabola. This is the lowest point, so we're coming up. And we should try to make it as symmetric as possible. So it'll look something like that. Again, I don't want to see any points. This should be a nice smooth curve. When we're looking at the y squared, again, the thing's opening up to the side. Then we are going to look at y equals -b over 2a. In this case, a is 1, b is 3, c is 0. So we get -3 over 2 times a is 1, or just -3/2. If you plug that back in, f of y is equal to -3/2 squared plus 3 times -3/2. So if this comes out to be a -6.75, if we think about this as being -1.5, again, we're going to have to adjust our axes on this so that we can fit. We really could just kind of get rid of the decimal places here and think about this as 5 and 10. In this case, our vertex is at y equals -1.5, and again, this is the y, so it's kind of the opposite here. We also need to adjust the x-axis so that we can fit this on. So we'll make this 5 and 10 as well. So we end up with a vertex here at the point x is negative 6.75. So we're going to go back to negative 6.75, and then we're going to go down by 1.5. So somewhere about here. Then again, our axis of symmetry is going to be in the y direction. So keep in mind that we need to be symmetric. In this direction, we've got a y squared. It's positive. That means we're going to be opening to the right. And so we need to find, again, so this is going to be the line y equals negative 1/2 is our axis of symmetry. And so our intercepts in this case, if we factor, we had y squared plus 3y, set that equal to 0. We can factor out a y. We're left with y plus 3 equals 0. So we have y-intercepts of 0 and 3. If we plug y equals 0 in, we get an x-intercept of 0. So we know we're going to go through the origin here. We also know that we are going to go through the y-axis at the point negative 3. So we're going to go through about here. So this is a pretty squished parabola with the way our axes are, and our parabola would look like this. So I want you to pause the video here and try the last example. So for this one, you should have found that your vertex was at the point negative 1, 0. Your axis of symmetry was at negative 1. And you had some intercepts here. You had x equals negative 1 with multiplicity 2 was an x-intercept, and your y-intercept was 1. So the x-intercept happens to be at the vertex, and it's multiplicity 2, so we know it's going to bounce here. And we know we had our y-intercept here at 1, and it's going to be symmetric, so we can also put that point back there at negative 2, 1, and we can draw our parabola. So this concludes the first video for section 20.2.